Okay, ladies and gents, we're going to see how quickly we can get this last video done. 'Cause I know I already took up too much time on the previous one. All right, so let's get into it. We're going to start talking about congruence of triangles, and we're not going to leave this anytime soon, so get used to it. Okay. First of all, congruence, going back to 7th and 8th grade, maybe even before that. Two figures are congruent if they have exactly the same shape and exactly the same size. Okay, so to make sure that you have congruent figures, what you're going to need to make sure is that you have all of the corresponding angles and all of the corresponding sides congruent to each other. Okay, for this situation, for this example right here, angle A here and angle N are corresponding sides, so they would have to be congruent. Okay, angle C, angle P are corresponding, so they would need to be congruent, okay, etc. with all the angles. Same thing with the sides. Side AB and side NO are corresponding, so they would need to be congruent, etc. for all of the sides. You can only say that a figure is congruent to another figure if all of the corresponding sides are exactly congruent. And you need to make sure that you say it in a specific way, as our next slide will show. But take a look at this down here. Triangle ABC, if we know that all of these parts are congruent to each other, that correspond to one another, we can say that triangle ABC and triangle NOP are congruent to each other. Another way of saying that would be BCA, triangle BCA is congruent to triangle OPN. Instead of starting at A like we did over here the first time, what we're going to do is actually start at B and say BCD, or BCA, is congruent to OPN. Okay? Exactly like that. And obviously, you can come up with another way of doing this as well. I'll leave that to you to figure out. Okay. Important to notice, though, we can talk about two ways to. Just give me a second. Oh, there is a page in your handout that is not here. So I'm just going to add a page real quick and talk about two ways to say that something is congruent, and or a couple of ways to say that something is congruent that work, and a couple of ways that don't. Okay? So let's say that we had this triangle here. I should not use the magic pen, I'm sorry. Okay? Say we had A, B, C, and we have D, E, F, and just so we don't have any repeats, let's give ourselves some angles. Let's say this is 40. Let's say this is 60. Let's say that the other one then would be 80. Clearly, they are not labeled like that, or the shape is not drawn like that, but let's say it was. Okay? So, there are a couple of ways you could say that these are congruent. You could say that triangle ABC is congruent to triangle DEF. Okay? You could say, starting with B instead, triangle BCA is congruent to triangle EFD. What you cannot say is something like this. Triangle ABC is congruent to triangle EFD. Because you have to make sure that the order you write it in is the order of corresponding parts. A has to correspond to, or the first letter has to correspond to the first letter. The second letter has to correspond to the second letter. The third letter, etc. You get the idea. A and E do not correspond to each other because those are these guys over here. This one here, this one here. A has a 40-degree angle. E has a 60-degree angle. So clearly this one does not work. Okay? I think you get the idea. We're going to move on. Okay. This is just a list of the corresponding sides, and I think we've already talked about that. Okay. So, we have these two triangles here, and we are going to talk about what their corresponding sides are. What is the part that corresponds to side AB? Okay, so let's look at our picture. We look for AB. We see 3 lines here, so let's look for the other one that says it's congruent. So we know that our corresponding side is DE. However, it's not DE, is it? Because you have to make sure that you are going in the exact same order, okay? So when we talk about this side right here, okay, we are going from angle A to angle B. That is the angle that has these 2 equivalences and the angle that has the angle that has the 1. We have to do the same thing on the other side. We go from the angle that has 2 to the angle that has 1. Okay? So when we name this AB, we have to then go the same way and label the other one ED. Okay? It's a fine point that is easy to make a mistake on, so you need to be very careful. Same thing works with angles. When we talk about CAB, okay, we need to talk about which angle is congruent to that, and that's the one with 2. Okay, and we are going from C, which is the one with 3 lines. So we go CED would be the one that is corresponding. Okay, just like so. Angle D is going to correspond to which other angle? Well, that's pretty easy. Angle B, so that's going to be the same there. CD. Once again, we have to be careful to make sure we're going in the same direction. We go from the angle that has 3 rings to the angle that has 1. We need to do the same thing when we're talking about its corresponding side. We need to go this way from the 3 to the 1. So it is CB, not BC. Okay? That'll allow you guys to figure out why the rest of these answers are like so. Okay? And I am going to move on. Okay. If triangle ABC is congruent to triangle EFG, name all the corresponding parts. If you need to draw a diagram. I need to draw a diagram because I have trouble thinking about this if I do not have a picture. And there's nothing wrong with drawing a picture. Okay? So, this is triangle ABC. This is triangle EFG. And then let's just go ahead and label everything. This part corresponds to that. This one to that. This one to that. And let's use a different color to do the angles. 1, 1, 2, 2, 3, 3. And then you can go ahead and label corresponding sides and corresponding angles. You would do it like this. Corresponding sides, AB corresponds to EF, etc. I'm not going to list them all out because I'm trying to be quick on this, but you can figure out what the rest of them are. Okay. What part corresponds to angle J? Okay. These two, we are told, are congruent to each other. Okay, so we know we're going to have corresponding parts. Well, we know that our obtuse angle is this one here and this one here. So really, they're just flipped images of each other. So the one that's going to correspond to angle J is going to be this one right here. Because if we imagine taking this shape right here and flipping it around as if it had an axis through it, then we would get the same image. So J and P are going to be the ones that are going to correspond. What's the corresponding part to Q? Same picture for the same reason. J, K, L. Okay, for the same reason, we have angle Q and angle K that are going to correspond. QP. Here's the one where it gets a little bit tricky. You have to make sure that you are going in the same direction when you talk about this. So QP means we're starting at this angle here, and we're winding up at this one here. We need to start with the part that corresponds to Q, that's K, and go to the part that corresponds to P, that's J. So when we name our corresponding side, it's KJ, not JK. Okay? Good. Write a congruent statement. These triangles are congruent, but how would we name it? You have to make sure you go in the same order. Okay? So I don't know which one they're going to want, so let's just go through these in order and see which one is true. Triangle BVC. Okay? That is this one, BVC. We start at the single, we go to the right angle, and then to the double. Okay? So we need to start from the single, go to the right angle, and then the double. So if we were going to start with BVC, we should say it was congruent to XZC. This one says XCZ, so that is not correct. Okay? So this one is going to be wrong. Let's try again. We have XCB, that is XCB. Well, that's wrong all of us right away, because that's not even a triangle. So we don't even have to do any work there. Okay, the next one, VBC. We start at the right angle, we go to the single, and then the double. That's the right angle, the single, and then the double. And we need to do the same thing if we were going to say they were congruent. Right angle, single, double. So it should be Z, then X, then C. Z, then X, then C. We have a winner. We don't actually need to do the next one, because if there's only one right answer, then we know it's this one. Okay? Complete the congruent statement. X, Y, Z is congruent to, and I'm going to let you do this one on your own. Okay? There's one theorem for today, third angles theorem. This one's really, really simple. You still need to know it, though. If two angles of a triangle are congruent to two angles of another triangle, then the third angles are congruent. What in the world did he just say? Basically, if you have two triangles, and you know that one angle is congruent to another, a second angle is congruent to the second one, it absolutely makes sense that the third angle is determined, because each of these triangles has to add up to 180 degrees, so there's only one measure it could possibly be. So Q and T have to be the same, okay? And they would actually be like that, okay? So I will leave it to you to try to put in your own words what the reason for that would be. But if we know that two angles are congruent to each other in two triangles, then the third angles must be the same by the theorem 4.3, third angles theorem. Okay, so let's go ahead and use that. We have these two triangles here, and we know that this one here and this one here are the same. This one over here is labeled 45 degrees, so let's go ahead and just label this one 45 degrees. Okay, we know that this one here and this one here are the same. Okay, I know that this one's 75, so let's go ahead and label this one. This is going to be 75. Okay, and then that means that by the third angles theorem, this and this must be the same. Okay, well, I know I can figure out what this one is right here, because the triangle has to add up to 180 degrees. So I can do 180 minus 45 minus 75 is going to equal, this one's 120 together, so 180 minus 120, this has got to be 60. I know by the third angles theorem that this angle right here and this angle right here have to be the same, because the other two angles were corresponding. Okay, so 60 has to equal 2x plus 40. And so I'll just solve for x. Minus 40, minus 40, 20 equals 2x. Most of the time that means x equals 10. I'm sorry, I made it look like less than. X equals 10. Okay? And we're good. What is the measurement of angle J? Okay? Same thing over here. We know that that this one and this one are congruent. We know this one and this one are congruent. Okay? So that means that these third angles must automatically be congruent to each other. So I can figure out what angle R is just by doing my rule that I've known since middle school. 180 minus 117 minus 48. Let's see, 117 and 48 together, so I'm going to subtract 150, 165. Okay, so that means that 180 minus 165, this one has to be 15 degrees. Okay, which means by the third angle theorem, this one has to be 15 degrees because the first angle was congruent to the first angle, second angle congruent to the second angle, so the third angles must be congruent. Okay, same thing here. I'm going to let you solve this one on your own because it's pretty simple. I'm going to move on. Okay, find the value of x. I like this one. This looks fun. Okay, so we've got this congruent to that. So first thing I'm going to do, I'm going to label what this one is, 78 degrees. For the same reason, I know that this one is 62 degrees. Okay, and I know that the third angles must be congruent. Okay, so I know that whatever this measure is, and I'm going to find it in a second, 180 minus 62 minus 78, I know that whatever this ends up being is going to also equal angle B over here. Okay, so 180 minus 62 minus 78, let's see what those add up to together, that's 130, 140. So 180 minus 140 equals 40. This has to equal 40, so this has to equal 40, which means that 40 is equal to 3x plus 10. I can look at that and know that the answer is 10, but minus 10, 30 equals 3x, x equals 10. Let's see. Hey, and they agree with me. Cool. Let's move on. Final one. Theorem 4.4. If this looks somewhat familiar, it should, because theorem, what was it, 2.1 and 2.2, the properties of line segment congruence and angle congruence, okay? Same thing goes with properties of triangles. Triangles, triangle congruence works the same way, I'm sorry. So if we know that one triangle, if we have one triangle, I didn't mean to do that. If we have one triangle, it must be congruent to itself. That's the reflexive property. But remember, we can't just use reflexive property that talks about numbers. The reflexive property is true of congruent triangles as well. If you have a triangle, it's congruent to itself. That clearly makes sense. Symmetric property works just like you would expect too. If one triangle is congruent to a second, then that second must be congruent to the first. Okay? This is our basic symmetric property, but this time symmetric property with congruent triangles. And finally, transitive property, our favorite one. And what is this very, very similar to? Good. I'm glad that some of you are saying chain rule to yourselves right now. Okay? We have one congruent to a second. 1 is congruent to 2. 2 is congruent to 3. Therefore, what? Triangle 1 must be congruent to triangle 3 by the transitive property of congruent triangles. I don't think you will have a hard time remembering this one because we've done so much with these properties. Okay, I think that's it. So enjoy filling that in, and I look forward to seeing you in class.